The cosmos beckons us. It has always been a source of wonder and mystery, a vast expanse that challenges our understanding and ignites our imagination. From the earliest days of stargazing to the modern era of space exploration, humanity has been driven by an insatiable curiosity to explore the unknown. The stars, planets, and galaxies beyond our own have captivated our minds and inspired countless generations to look up and dream of what lies beyond. Mars, our celestial neighbor, holds the promise of a new home for humanity. This red planet, with its rugged terrain and thin atmosphere, presents both challenges and opportunities. Scientists and engineers have been tirelessly working to understand its environment, from the composition of its soil to the potential for water beneath its surface. The rovers that traverse its landscape send back invaluable data, painting a picture of a world that, while harsh, is not entirely inhospitable. The dream of setting foot on Mars is no longer a distant fantasy but a tangible goal within our reach. It's a chance to expand our horizons, to push the boundaries of exploration, and to secure the future of our species. The journey to Mars is not just about reaching a new destination, it's about the spirit of adventure and the quest for knowledge. Each rocket launch, each mission, and each technological breakthrough brings us one step closer to making this dream a reality. The development of sustainable habitats, advanced life support systems, and efficient propulsion technologies are all critical components of this grand endeavor. Colonizing Mars is a daunting challenge, but one that we are ready to embrace. The harsh conditions, including extreme temperatures, radiation, and dust storms, require innovative solutions and resilient technologies. Yet the potential rewards are immense. Establishing a human presence on Mars would not only ensure the survival of our species in the event of a catastrophe on Earth, but also open up new frontiers for scientific discovery and economic opportunities. The vision of a thriving Martian colony is a testament to human ingenuity and determination. This endeavor will require the combined efforts of nations, private companies, and brilliant minds from all walks of life. International collaboration is key to overcoming the technical, financial, and logistical challenges of such a monumental task. Governments, space agencies, and private enterprises must work together, pooling their resources and expertise to achieve a common goal. The spirit of cooperation and shared vision will drive us forward, fostering innovation and accelerating progress. Conferences, workshops, and joint missions will pave the way for a united effort to conquer the final frontier. It's a mission that will inspire generations to come, a testament to the indomitable spirit of exploration that burns within us all. The journey to Mars will capture the imagination of young and old alike, sparking a renewed interest in science, technology, engineering, and mathematics. Educational programs and outreach initiatives will play a crucial role in nurturing the next generation of explorers, scientists, and engineers. As we train astronauts and prepare for the challenges ahead, we are also planting the seeds of inspiration in the minds of future pioneers. The story of our journey to Mars will be one of courage, perseverance, and the unyielding human spirit. Mars presents unique challenges that we must overcome. The vast distance between our planets is a formidable obstacle. A one-way trip to Mars could take 6 to 8 months with current technology. Communication with Earth would be significantly delayed, making real-time conversations impossible. The Martian environment is harsh and unforgiving. The atmosphere is thin, composed mainly of carbon dioxide. Temperatures fluctuate wildly, and there's no global magnetic field to shield from harmful radiation from the sun. Building a self-sustaining colony on Mars will require ingenuity and resourcefulness. We need to find ways to produce food, water, and oxygen on a planet where these resources are scarce. Shelter will be crucial to protect colonists from the harsh Martian environment. Innovative habitats will need to be designed to withstand radiation, regulate temperature, and provide a safe and comfortable living space. SpaceX, led by Elon Musk, has taken a bold stance on colonizing Mars. Their ambitious plans involve developing reusable spacecraft and utilizing in-situ resource utilization, or ISRU. This means using resources found on Mars to sustain the colony. NASA, with its decades of experience in space exploration, brings invaluable expertise to the table. Their knowledge of propulsion, life support systems, and long-duration space travel will be critical to the success of any Mars mission. Section 5, Starship, a vehicle for Martian dreams. SpaceX's Starship is a revolutionary spacecraft designed to transport humans and cargo to Mars and beyond. Its fully reusable design aims to significantly reduce the cost of space travel. Starship is designed to be a multi-purpose vehicle, capable of landing on the Moon, Mars, and potentially even venturing further into our solar system. Its development represents a significant leap forward in our ability to explore and colonize other worlds. Section 6. Beyond chemical rockets, the need for nuclear propulsion. For over half a century, chemical rockets have been the backbone of space exploration. These powerful machines have taken us to the Moon, launched satellites into orbit, and even sent robotic explorers to the far reaches of our solar system. However, as we set our sights on more ambitious goals, such as manned missions to Mars and beyond, the limitations of chemical rockets become increasingly apparent. The vast distances involved in interplanetary travel require propulsion systems that are not only faster, but also more efficient. Chemical rockets, while powerful, are constrained by the amount of fuel they can carry and the energy they can produce. This means longer travel times and increased risks for astronauts on long-duration missions. Enter nuclear thermal propulsion, or NTP. This advanced technology offers a promising solution to the challenges of deep space travel. By harnessing the immense energy produced by nuclear reactions, NTP systems can achieve much higher efficiencies than their chemical counterparts. The principle behind NTP is relatively straightforward. A nuclear reactor generates heat, which is then used to heat a propellant, typically hydrogen, to extremely high temperatures. The heated propellant expands rapidly and is expelled through a nozzle, creating thrust. This method of propulsion can propel spacecraft at much higher speeds than traditional chemical rockets. In fact, it has the potential to cut the travel time to Mars in half, making missions not only faster, but also safer for astronauts. With reduced travel time, the exposure to harmful space radiation is minimized, and the overall mission duration is shortened, reducing the amount of supplies needed. As we look to the future of space exploration, nuclear thermal propulsion stands out as a key technology that could enable humanity to reach new frontiers. By overcoming the limitations of chemical rockets, NTP could pave the way for sustainable and efficient interplanetary travel, bringing us closer to realizing our dreams of becoming a multi-planetary species. Section 7. NASA's expertise. Powering the journey to Mars. NASA's experience in developing and operating nuclear-powered systems, such as the radioisotope, thermoelectric generators, or RTGs, used on missions like Voyager and Curiosity, will be invaluable in developing safe and reliable NTP systems. NASA's expertise in logistics and mission planning will be crucial for coordinating the complex operations required for a Mars colony. Their experience with the International Space Station has provided valuable lessons in long-duration space habitation, which will be directly applicable to a Mars mission. Section 8. Research and development, the key to Martian success. Before we send humans to Mars, extensive research and development are needed. This involves a multifaceted approach, combining the expertise of scientists, engineers, and researchers from various fields. The journey to Mars is not just about reaching the planet, it's about ensuring that humans can live, work, and thrive there. This requires a deep understanding of the Martian environment and the challenges it presents. We need to understand how to grow food in Martian soil. This involves experimenting with different types of plants and soil compositions to find the best combinations that can sustain human life. Researchers are working tirelessly to simulate Martian conditions in laboratories here on Earth, testing various agricultural techniques and technologies. The goal is to create a self-sustaining food supply that can support a colony on Mars for extended periods. Another critical aspect is how to protect colonists from radiation. Mars has a much thinner atmosphere than Earth, which means higher exposure to harmful cosmic rays and solar radiation. Scientists are developing advanced materials and technologies to shield astronauts from these dangers. This includes testing different types of radiation shielding in controlled environments and designing habitats that can provide adequate protection. Building sustainable habitats is also a major focus. Engineers are exploring innovative construction methods such as 3D printing to create durable and efficient living spaces on Mars. These habitats need to be self-sufficient, providing not only shelter but also life support systems, water recycling, and waste management. The aim is to create a home away from home that can support human life for years to come. Simulations here on Earth, like the Mars Desert Research Station, will play a vital role in preparing for the challenges of living and working on the Red Planet. These simulations allow scientists and engineers to test their theories and technologies in environments that closely mimic the conditions on Mars. By doing so, they can identify potential issues and develop solutions before actual missions take place. These simulations allow us to test technologies, develop procedures, and train future Martian explorers in a realistic, albeit Earthbound environment. Astronauts undergo rigorous training to prepare for the physical and psychological challenges of a Mars mission. They practice using the equipment, conducting scientific experiments, and living in confined spaces for extended periods. This comprehensive preparation is essential to ensure the success and safety of future missions to Mars. Section 9. Inspiring the Future: Public Support and Ethical Considerations. The endeavor of colonizing Mars requires not just technological prowess, but also public support. Inspiring future generations to dream of reaching for the stars is crucial for sustaining this grand ambition. Ethical considerations must also be addressed. We must ensure the preservation of any potential life on Mars and proceed with a sense of responsibility for the planet we seek to inhabit. Colonizing Mars is not just about conquering a new frontier, but about becoming caretakers of another world.